Hey everyone, and welcome. Today, we're diving into one of the most important rules for writing good, clean software that's built to last, the single responsibility principle. Now, it might sound a little academic, but trust me, getting this one concept right will totally transform how you build code.
Okay, to really get this, let's start with a super simple idea. You've got two options. On one side, you have a Swiss Army knife. It's cool, right? It does a ton of stuff, but what happens if the little screwdriver bit snaps off? The whole tool's kind of hobbled now. Now, on the other side, you've got a toolbox. Every single tool in there has exactly one job. If your hammerhead gets loose, you just get a new hammer. Your screwdrivers, your wrenches, they don't care. They're totally fine. This, right here, is the big idea we're about to see in the world of code. So, here's our game plan. First, we'll look at the problem, what I call the do-it-all class. Then we'll nail down the principle that fixes it, see how to actually separate things, walk through a real-world example, talk about the massive payoffs like testing and maintenance, and we'll wrap up with a simple test you can use on your own code today. All right, first up, let's meet the code version of that Swiss Army knife. It goes by a few names, but my favorite is the God class. You know, the one that tries to do everything all by itself. Now, this is where the problem really starts to become clear. Let's imagine a class called user. On the surface, it seems fine. It holds user data. But then, it also handles saving that user to the database, and it sends welcome emails, and it also generates PDF reports. Now look at that reason to change column. You've got business rules changing, which the product team cares about. You've got the database tech changing, which is the DB team's problem. Then the email service changing, which is on the ops team. And finally, the report format changes. That's the analytics team. You have 4 different teams with 4 totally separate reasons, all needing to change the exact same file. And you know what that leads to? Absolute chaos. Your code becomes incredibly fragile. A tiny change to the reporting logic could accidentally break the email system. It's a total nightmare to maintain because all these different jobs are tangled together like a ball of yarn. And testing? Forget about it. To test one simple business rule, you might have to create a fake database, a fake email server. It's just slow and complicated. Not to mention the constant merge conflicts when all those different teams try to make changes at the same time. So that's the mess. How do we get out of it? Well, the answer is this beautifully simple idea, the single responsibility principle, or SRP for short. Now, this is the most important part, so listen close. A lot of people hear single responsibility and think it means a class should only do one thing. But that's not quite right. The real, much more powerful definition is that a class should have one and only one reason to change. This little switch in thinking, from what the class does to why it changes, is the whole secret. And here's another way to put it that just makes it click. An actor here is basically a group of people who want a change. It could be a user, a stakeholder, or a team. So if your class is being changed because the database team needs something and because the analytics team needs something else, it's serving 2 different actors. And that's your giant red flag that it's violating the principle. Okay, theory time is over. We get the principle. Now let's get practical and see how we actually fix that broken user class of ours. The main technique we use is a refactoring called extract class. And yeah, it's as simple as it sounds. We're basically doing some code decluttering. We find a specific responsibility, like all the email stuff, and we pull it out of our big, messy class and give it its own brand new, focused home. So we go from one class, juggling 4 jobs badly, to 4 separate classes, each one doing its one job perfectly. And here's the beautiful result. We have a user repository, and its only reason to change is if something about the database changes. We have an email service that only changes if our email provider changes. A report generator that only changes if the report layout changes. And our original user class? Look at it. It's clean, simple, and only has to worry about one thing, holding user data and business logic. So much better. Now let's see how this plays out in a bigger system that we've all probably used at some point, an e-commerce site. So picture an order class in an online store. It's really common to see these classes do everything. They calculate the total price, they send out the confirmation email, and they tell the warehouse to update the inventory. Now, based on what we've just learned, take a second. Why is this a classic textbook violation of the single responsibility principle? It's because there are 3 completely separate reasons this class would need to change. The finance department might want to add a new type of discount, which changes the pricing logic. The marketing team might decide to add SMS alerts, which changes the notification logic. And the warehouse operations team might get a new inventory system, which changes the inventory logic. Each of these things is its own world, and a change in one shouldn't even have the chance of breaking the others. Okay, so we've put in the work, we've separated our code into these nice, clean, focused classes. What do we actually get out of it? Let's talk about the payoff, because it is massive. When it comes to testing, the difference is literally night and day. Before SRP, trying to test one little piece of business logic was a pain. You had to set up all this complicated stuff, a fake database, a fake email server. It was a mess. But after we apply the principle, testing is a breeze. You can test the user repository all by itself, without even thinking about how emails or reports work. Your tests get faster, they get simpler, and way, way more reliable. And the long-term benefits are just huge. We get what's called high cohesion. That's just a fancy way of saying that code that belongs together stays together. We also get reduced coupling, which means our classes aren't all tangled up with each other. And all of that leads to code that is so much easier to maintain, so much easier to find and fix bugs in, and way more flexible when things inevitably change down the road. So to wrap this all up, I want to leave you with a really simple litmus test, something you can start using on your own code, like the minute this is over. Next time you're looking at a class or a module in your project, just stop and ask yourself this one powerful question. How many different, independent reasons are there for this piece of code to change? Think about the business rules, the database, the user notifications, an API you're talking to. If you start counting on more than one finger, you've probably found a problem. That's it. The magic number is 1. If you can look at a class and honestly say there is only one reason, one actor, that would ever cause you to open up and modify this file, then you've nailed the single responsibility principle. But if the answer is 2, or 3, or even more, you know exactly where you need to start refactoring.
And here's the final thought that ties it all together. Just ask yourself, who changes this class? If you know a file gets changed by the backend team for database stuff and also by the ops team for infrastructure stuff, you have found a crystal clear violation. So the question I want to leave you with is this: how many of your classes are trying to serve more than one master? Thanks for tuning in.